Question 26. Ethanol and potassium dichromate oxidizing agent was refluxed for 1 hour. When they say this, actually we will understand their intention is actually to change ethanol to ethanoic acid. Right? We might get aldehydes along the way, but that's not what we want. We want to find out how much ethanoic acid do we eventually get. So the desired organic product, the ethanoic acid, was then collected, and then we get the yield to be 60%. So we form an equation. Ethanol, right, forms ethanoic acid, CH3 COOH. Now you might wonder, what are the other things that is actually involved? Well, if we were to really balance the equation, we actually have water, and then we have our oxidizing agent represented by square bracket O and 2 of it here. Right now, if you're wondering what if you're not sure that you need to write this equation now and water and all that, well, it's fine if you don't have this. All you have to know is compare the carbons. We have 2 carbons for ethanol, we have 2 carbons for ethanoic acid. The ratio must be 1:1, right? So that is more important, that the ratio between the ethanol and the ethanoic acid is 1:1. Now we have 2.3 grams of ethanol, and then they say that the yield is 60%. So 60% of the 2.3 grams, you can view it as 60% of the 2.3 grams of ethanol was successfully converted to the ethanoic acid. So how much ethanol was converted? We get 60% multiplied by the 2.3 grams that was used. Right, and then from the mass, this is the mass that was used. One 1.38 grams of ethanol was successfully converted. So we can view the question again afresh as this is 1.3 grams. What's the mass of ethanoic acid used? So all we have to do is convert this to number of moles, and then we have the moles of ethanoic acid, and then we will have the mass of ethanoic acid. So moles of ethanol, the mass that was successfully converted, divided by this MR, which is actually the same as the moles of your ethanoic acid, because the ratio is 1:1. Alright, once we have that, the mass of ethanoic acid number of moles multiplied by the MR of ethanoic acid, we will get 1.8 grams. So that is the mass of the ethanoic acid produced when 60% of your ethanol was converted. We have this molecule that contains 2 functional groups. Right? We have, this is the aldehyde functional group. I'll put it as 1, and we have our ketone functional group. I'll put it as 2. Which of these reagents will react with only one of the functional groups? Right? So acidified potassium dichromate will react with aldehyde. It can oxidize aldehydes, whereas ketones will not be oxidized by acidified potassium dichromate. So okay, I'll put 1 here to say that it reacts with 1 but not with 2. 2,4-DMPH will react with carbonyl groups, so it will react with both aldehydes and ketones. Hydrogen cyanide will react with both carbonyl groups. It will step up. So 1 and 2 will react with hydrogen cyanide, and sodium hydroxide will react with neither 1 nor 2. So the one that only reacts with one of the two will be the dichromate. Okay, reacts with aldehyde but not ketone. (28) We have an ester. What is the name and how does its boiling point compare to butanoic acid? First of all, the name. Ester, when we break it up, we focus on the ester bond. Alright, then we break it, we will break the ester bond. So if you visualize, this is actually the alcohol part, and this is actually the acid part. The C double bond O is the acid part. So the alcohol 1, 2, 3 is a 3 carbon alcohol, so it is actually, or it can be visualized as originated from propanol. The acid has only 1 carbon. This is methanoic acid. So if we were to ask what alcohols and acid could be used, these are the two that we can put together, right? But what is about the name? The name actually derives from them. We will name it based on the alcohol first, propyl, then the acid, methanoate. So the name of this ester is propyl methanoate. Right, boiling point. This is a polar molecule. Right, polar molecule, it will have permanent dipole interactions. Comparing it to butanoic acid, because of this group, the carbonyl groups, the carboxyl group, it will allow butanoic acid to have hydrogen bonding, okay, which is stronger than permanent dipole. So boiling point of your ester with permanent dipole is lower than that of butanoic acid, which has hydrogen bonding. So we have D. Polymerization of monomers. We have this monomer that has a double bond, so it will undergo addition polymerization. Now the easiest way to look at this is to actually change the molecule until you can visualize it as a giant H shape. Right, so we have CH2, H, and then CH2OH. Right, when I say giant H shape, what I'm saying is this. Okay, put the double bonds on here, the horizontal part, and then push all the rest up, down, and then what happens when they polymerize? This double bond will become a single bond, and then it will connect to the left monomer and the right monomer. Alright, so we have B as the repeating unit.